Have you ever heard the one about the bumblebee? You know the old story that says, according to the laws of aerodynamics, bumblebees shouldn't be able to fly. Their wings are too small, their bodies are too big, and they just don't have what it takes to get off the ground. For decades, this little fact has been a popular tidbit, a symbol of defying the odds. But is it actually true? Did science really get it so wrong? Today, we're diving deep into the fascinating story of the bumblebee flight paradox to uncover the truth. The tale seems to have started around the 1930s. The story goes that an aerodynamicist was having dinner with a biologist. After a few drinks, the biologist described the bumblebee, and the aerodynamicist, using some quick back-of-napkin calculations, declared that, based on conventional airplane physics, its flight was impossible. The numbers just didn't add up. The story spread like wildfire, becoming a popular anecdote. It was the perfect metaphor. The bumblebee, unaware of the scientific impossibility of its flight, just flies anyway. It's inspiring, right? But here's the catch. The initial calculations were fundamentally flawed. The problem was that early aerodynamic models were designed for fixed-wing aircraft like airplanes. These models treat wings as rigid, smooth surfaces that generate lift by having air move faster over the top than the bottom. Think of an airplane wing slicing cleanly through the air. That's a very specific, very simplified way of looking at flight. And when you apply those simplified equations to a bumblebee, you're right, it doesn't work. The lift generated seems to be far too weak to support the bee's chunky body. But here's the crucial mistake. A bee's wing is nothing like an airplane's wing. So, how do they really fly? It took a while for science to catch up, largely because we needed better technology to see what was happening. We needed high-speed cameras that could capture the incredibly fast and complex motion of a bee's wings. A bumblebee beats its wings around 200 times per second. That's not a simple up and down flap. It's a sophisticated combination of rotation, sweeping, and twisting. When scientists could finally slow this motion down and study it, they discovered the secrets. It turns out, bumblebees don't just generate lift in the conventional way. They use a few clever aerodynamic tricks. One of the most important is something called a leading edge vortex. As the bee's wing sweeps forward, it creates a small, stable swirl of air, like a miniature tornado, right on the top surface of the wing. This vortex creates a pocket of very low pressure, which essentially sucks the wing upwards, generating a huge amount of extra lift. This isn't something that happens with the rigid wings of an airplane, which are designed to avoid this kind of turbulent air. For the bumblebee, this messy airflow is the key to its power. But that's not all. The way they flap is also genius. They don't just flap up and down. Their wings sweep back and forth in a sort of sculling or figure-8 motion. As the wing reverses direction at the end of each stroke, it performs a rapid rotational flip. This flip is incredibly important. It sheds the old vortex and helps create a new one for the return stroke. This process, called wake capture, allows the bee to get an extra push from the turbulent air it just left behind. It's like a swimmer getting an extra kick off the wall of a pool. They are essentially recycling the energy from their own wake. So the bumblebee doesn't defy the laws of physics at all. It just uses a much more complex and elegant set of physical principles than our early models could account for. The paradox was never in the bee's flight. It was in our limited understanding. We were trying to fit a square peg into a round hole, applying airplane physics to an insect that evolved a completely different, and in many ways, more sophisticated method of flying. This discovery didn't just solve the bumblebee mystery, it opened up a whole new field of study in bio-inspired robotics. Engineers are now trying to build micro-drones that mimic the flapping, rotating flight of insects because it's so much more agile and efficient at small scales. The story of the bumblebee flight paradox is a wonderful lesson in scientific humility. It reminds us that our models and theories are only as good as our observations. When something in nature seems to defy our laws, it usually means we're the ones who need to look closer and expand our knowledge. The universe is full of elegant solutions, and the bumblebee is a perfect, fuzzy, buzzing example. So, the next time you see a bumblebee clumsily bouncing from flower to flower, remember you're not watching something impossible. You're watching a master of aerodynamics at work, a tiny marvel of natural engineering that took us decades to fully appreciate. Thanks for joining me on this journey into the world of bee flight. If you found this as fascinating as I do, be sure to hit that like button and subscribe for more deep dives into the wonders of science. Let me know in the comments what other scientific myths you'd like to see busted. Until next time, stay curious.